Hello YouTube, today we're going to be going over Norton equivalent exchanges, and we're going to use the similar problem that we used for my video on the Thevenin equivalent exchange, but we're going to just solve it using a different approach. So let's take a look. So in the previous problem, we had to find Ix. Well, in this problem we're going to find Iy by using Norton equivalent. So how we can do that? Well, first let's talk about what Norton equivalence is. Norton equivalence is you take a voltage source and it becomes a current source in parallel with resistors. So let's take a look at what that means exactly. So let's take our battery here. So we have our regular circuit, and we're going to take the battery and we're going to make it a current source with in parallel with the resistor here. So now that we have that, we can find what the current source is in terms of amps by using Ohm's law. And since I is equal to V over R, we know the original battery had a voltage of 180 divided by the resistance, which is 120, and that means we have 1.5 amps flowing through. Now I want to emphasize that the equivalence part of Norton equivalence. So a 180 volt battery is equivalent to a 1.5 amp current source in parallel with 120 ohms resistor. So now we can rewrite this circuit by simply summing the current sources. It's really awesome. So current sources in parallel actually combine, they sum. So we have the 24 volts, but notice how these are in opposite directions, but the 24 volts is much larger in magnitude than the 1.5, so the current's going to be flowing downwards, or in this case counterclockwise. And then we're going to subtract the 1.5 since it's in the opposite direction of the current flow to give us 22.5 amps. So that's how we got 22.5 amps as our current source here. But we're looking for Iy, right? Whoop. So we can do that. So let's look at the circuit again. Enlarged, I had to make it a little bigger so we can see it. So we just have a current source and two resistors in parallel. So let's see what the equivalent resistance is. And 60 ohms in parallel with 120 ohms. You can do the math. 1 over 60 plus 1 over 120 and 1 over all of that will give you 40 ohms. So from Ohm's law, where V equals IR, we know our current source is 22.5 amps and our resistance is 40 ohms. So the total voltage is 900 volts. But we're just looking for Iy. So since Iy just flows through the 60 ohm resistor, then Iy is simply the total voltage over the 60 ohm resistor. And we've found the total voltage is 900 divided by 60, and that means Iy is simply 15 amps. So there you have it, our Norton equivalent exchange and a problem where we had to find the current going through a resistor. So I hope this helped. Good luck and happy studying.